The moon is no longer a mysterious frontier of exploration. In the 21st century, it's become the most coveted location to establish what will be the most lucrative mine sites we've ever known. To talk more about this, we're joined by Jonty Horner, Professor of Astrophysics at the University of Southern Queensland. Professor, thank you so much for joining us today.
It's an absolute pleasure. Thanks for having me.
A huge subject that we want to discuss with you. There are potentially billions of dollars worth of resources in outer space, on the moon, on asteroids, and potentially on places that we don't even know exist at the moment. How close are we to actually mining some of these resources?
Oh, it's a really interesting one, and the numbers get mind-boggling. People have estimated that one asteroid alone could be worth $2 quadrillion, which is 1,000,000,000,000, which just makes my head hurt. And it's probably not that realistic. So if you get lots and lots of something, the price drops, obviously. But it's something people are looking at really, really seriously, both at a government level and also from a private business point of view. The most obvious example is the American ongoing effort to make a base probably at the south pole of the moon where people can live and work for a protracted period of time. And one of the things that will be a hurdle to overcome with that is the resource problem. Primarily, how do you get water and fuel there? If you've got to ship it from the Earth, it's ridiculously expensive. So one of the things they're looking at quite seriously is extracting water from beneath the surface of the moon in the South Pole, where we think there could be a lot of water ice trapped. And that will require some innovation. It will require development of new technology. But if they can overcome those hurdles, having a ready supply of water means that you can break that water into its component hydrogen and oxygen. It means you have the hydrogen and oxygen to use as fuel for your rockets. So suddenly you don't have to bring all your fuel with you from home. You can make it locally, makes things cheaper. It also means you have a source of water to drink, a source of oxygen to breathe. It's really an effective way of lowering the costs and essentially making a base like that self-sufficient. So I think one of the first things people are going to be looking at mining off Earth will actually be water, which to some degree is surprising. People always imagine platinum and the rare earth metals and things like this. But water is going to be very valuable for our exploration of space. But there are other things out there as well. There are things that on Earth are scarce. They're not actually scarce in the interior of Earth, but there's not much of them on the surface. Things like the rare earth metals, which form a significant fraction of what's in my phone and everybody else's phone. They're not very common on the surface of the Earth. Extracting them is an incredibly toxic and unpleasant process. It's very environmentally damaging. And those metals are, if you pick the right asteroid, relatively common, comparatively common, out there on asteroids in space. Now, people are seriously looking at developing the technology to go to asteroids, extract these precious things, send them back to Earth. And that has two benefits. A, for the people involved, obviously, it generates wealth for them. They get to make a profit. That's why they're doing it. From the Earth point of view, though, it means we get more of a supply of these things that are critically needed, but very scarce. It also means we can move some of the most damaging and unpleasant mining off the Earth and therefore improve the environment here as well. So I'm really an optimist. I actually think there's something very positive about a future where we start getting some of our resources from beyond the outside of the Earth's atmosphere, essentially.
You've talked a lot about the innovation that's needed to make that happen. I mean, clearly at this particular point in time, it wouldn't be economically viable. So what needs to happen? What sort of innovation do we need to see to make this an economically viable process?
It's going to be really challenging, but it's the kind of challenge that really inspires people. Doing something that we've never done before gets people excited. And there will be innovation needed in terms of mapping the asteroids and working out which are the most valuable, which are the highest likelihood to give you a return on investment. Because you don't want, if you're a big company doing this, to have to explore 100 asteroids before you get to the right one, because then the cost is prohibitive. You want to be able to choose the right one right away. Once you get there, you need the technology to be able to extract what you're looking for and probably process it to send a processed product back to the Earth. Now, that sounds fairly straightforward. On the Earth, mining companies have been doing that for decades. But the problem is on Earth, we have gravity. We've got Earth gravity. If I pick my phone up and let it go, it falls. That's really important. If you try mining when you have a very weak gravitational pull, how will it work? How many of the techniques we can use on Earth are applicable off Earth? And I think there's a lot of discussion of the fact that when we go to mine off Earth, it will be new companies that are innovative and mobile that spring up to do that, rather than the traditional big mining companies on the Earth. In much the same way as when we saw the transition from the first handheld mobile phones to the smartphones, it wasn't the old companies that stayed there, but it was new companies who muscled in with their new product and took the market away. It's going to be a very similar thing, I think, where you won't have necessarily the big name mining companies taking a big role in this, but rather it will be new startups that fill that void, develop that technology, and reap the rewards.
You started off by talking about the fact that one of the most likely products to be mined is water and the numerous reasons why that's important. Are you confident where you sit now that there is indeed enough water to be mined under the surface of the moon to actually kickstart this process?
The moon has almost certainly got a significant amount of water there, and the more we study it, the more we think that that may be a larger amount of water than people thought. And only this week I've been reading research that suggests when the moon was young, it was very volcanically active. So volcanically active that it had an atmosphere. And that atmosphere would have allowed water vapor from the volcanoes to reach the poles of the moon and to essentially freeze out like frost, to be trapped there. And you could have far more than anybody imagined trapped under the surface. Now, we'll know for sure when we land at the South Pole and start exploring, but it looks very promising. But on a wider sense, water is actually incredibly common in the cosmos. Liquid water like we have on Earth, not so much because you need the right temperature and pressure for that, but water ice is everywhere. The comets at Great our Night Sky are water rich. The moons of Jupiter, Saturn, Uranus and Neptune are places with abundant water. So we are going to have a huge amount of water out there in the solar system to get our hands on. It will become a staple. The moon will probably be where we start, and we're fairly confident that there is enough there to get things going, yes.